Okay, welcome back to the third and final lesson for section 11.4. In this lesson, we're going to take a look at about 6 problems where we're going to be isolating the variable in a fairly complex equation. So let's go ahead and take a look at which one we're going to start with. This is going to be question 16. And the formula we're going to be given is a is equal to 6s squared. This happens to be the formula that computes the surface area on the side of a cube here. So let's see if we can get the focus that a little better. That looks good. And here we're going to solve for s. So we're going to get s by itself in this one here. Doesn't look too bad, but we have to be careful of a few things. We're going to divide both sides by 6. This is going to give us a over 6 is going to equal s squared. So when we do this here, the one thing we do have to be considerate of, we have to take the square root of both sides. In doing so, we're going to get the value of s being equal to plus or minus the square root of a over 6. Now I'm going to write this again just to give myself a little more room. I'm also going to put radical a over radical 6. I'm going to separate this out. The one thing I can't leave in this problem is I can't leave a radical in the denominator. So I need to separate this out, and then I need to multiply the top and bottom by radical 6. Multiplying radical 6 by radical 6, well, that's going to give us 6. Multiplying radical a times radical 6 will give us radical 6a, not forgetting the plus and minus, and those are going to be the two solutions for s. So we can leave the solution here in its final form as is, and that's the solution for 16. We're going to jump ahead a little bit, and we're going to go to question 20 next. In question 20, we're given the formula n equals k times q1 times q2 over s squared, and we want to solve for s once again. So first you see this looks a little unnerving, maybe a little confusing. And don't confuse q1 and q2 as exponents. These are like numbers that are below, so we're not going to take the square root of q squared to get q. So what we're going to do to tackle this question is I'm going to go ahead and rewrite this again. Is I'm going to multiply everything through by s squared. So this is going to give me n s squared equals k times q1 q sub 1 times q sub 2. I'm going to go ahead and divide everything through by n now. So it's going to be s squared is going to equal k q1 q sub 1 or kq and then q sub 2 over n. The next thing I'm going to go ahead and do is I'm going to take the square root of both sides again. And when I do this now, I'm going to kind of take the step and then write each one in its separate square. So the square root of s squared is s. This is going to be plus and minus. And this is going to be the square root of k q1 q sub 1 q sub 2 over the square root of n. And we'd almost be done except for one little thing. We can't leave the n down here by itself under a radical. So I'm going to multiply the top and bottom of this by radical n. And all the n is going to do here is go on the inside. So this is going to give me s equals plus or minus the square root of k q sub 1 q sub 2 times n. And this is going to be over just n. So we can't leave a radical in the denominator, and we can leave our answer in this final form. A little confusing when first seeing this, but hopefully not too extreme. Again, this will take some practice to understand this better. Let's go ahead and take a look at the next question, number 22. So number 22, we've got a volume formula where V is going to equal 3.5 times radical h, and this one we're going to solve for h. So this time we want the value of h in this one. So what we're going to do is we're going to divide both sides by 3.5. We're going to try to get radical h by itself. So that's going to give us v over 3.5 equals the square root of h. Well, if I want to do this one, I'm going to go ahead, I'm going to have to square both sides now. Again, if you want to stop the video to kind of write these out as separate steps, please feel free to do so. When I do that, radical h squared is going to give me h. Whatever I get over here is going to be my solution. So this is going to be v squared, and then 3.5 times 3.5 is going to be 12.25. Now, so all I have to do is multiply the decimals, 3.5 times 3.5. You'll get this as your answer. Because we are squaring it, there's no plus or minus. So don't get too hung up on the details in this. Let's go ahead now and let's take a look at 24. So 24 is going to read v equals pi r squared h. This particular formula happens to be the volume formula for a cylinder. And this one we want to solve for r. So we want to solve this one for r. So I'm going to try to get r squared by itself, so I'm going to divide both sides by pi h. So when I do that, I'm going to get volume divided by pi times h equals r squared. Just like we did in a few previous questions, we're going to go ahead and we're going to take the square root of this. So you want to write this down, write it down twice, and then on the second one, take the square root of both sides. Well, that's going to give us r is going to equal plus or minus, and again I'm going to separate this out, the square root of v, that's a v, divided by the square root of pi h. Again, I can't have the square root of pi over, or of pi h in the denominator, so I'm going to multiply the top and bottom by the square root of pi h. So for my final answer here, I'm going to get plus or minus. Well, radical pi times radical pi is just pi. Radical h times radical h is h. On the top, it's radical v times radical pi h. So it's just going to be radical v pi h over pi h, and that's going to give us the radius, plus or minus that. And there is our answer to question 24. Let's take a look now at question 26. And in question 26, we have the problem a squared plus b squared plus c squared is equal to d squared. And this one we're solving for c. Now, if I remember this correctly, this is used to solve for the length of a diagonal in like a shoebox, or we'll call it parallelepiped. So the first thing we're going to do is we're going to try to get c squared by itself. So in order to do this, we're going to subtract a squared and subtract b squared from both sides. So this is going to give me c squared equals d squared minus a squared minus b squared. Not bad. And then I'm just going to take the square root. And then that'll be c is equal to d squared minus a squared minus b squared. And you could probably write that a few variations, but it's perfectly okay to just leave the answer in this final form, with one exception. We have to make sure we put a plus and minus there because we did take the square root of that. So we can write our final answer in this form. So we're going to leave it like so. And finally here, let's go ahead and take a look at question 32 to wrap off the section 10.4. So we have w equals the square root of the quantity of, yeah, I'm thinking this must be a 1 in the formula here, so that's a 1. And that's going to be LC. We want to solve for the capital L. So strategy here, let's get rid of the radical like we did in chapter 10. So I'm going to take the original one here, and I'm going to square both sides. That's going to give me w squared equals 1 over LC. No more radical here now. So what I'm going to do now, I want to bring this L on the top, and I want this L in the bottom. So I'm going to multiply everything by LC. So this is going to give me LCW squared is equal to 1 because the LC cancels here. Now that I have it written this way, I can just divide by CW, or CW squared, I should say. And that'll give me L equals 1 over CW squared. And that's it. So, may not look so easy to you, may take some practice to do this. I imagine you may want to ask for some help on these in class. But this is probably about the toughest work that we're going to be doing, other than maybe 11.8, which is more word problems. But this is probably the most confusing section in Chapter 11. If you have any questions about this in class, please don't be afraid to confer with your classmates and ask me questions as well. See you in class.